Alright, continuation of numerical integration. We have spoken about the midpoint rule and also the trapezoidal or the trapezium rule, and what is left is the Simpson's rule. Right, so please note that of all three rules that we have learned, okay, the most accurate would be Simpson's rule because we are going to use two curves to approximate the area. Hence, the tendency of overestimating and also the tendency of underestimating would be very limited. Okay, so I'm going to go with this question. Okay, find the integral of 5 over x respect to x. X is from 1 to 5 using strips of width 1 over 4. Okay, note that Simpson's rule can only be used, or Simpson's rule is only applicable if you were to be given even number of strips. So when I look at width of 1 over 4, I wouldn't know how many strips yet, hence I'll have to look for the number of strips. So width is equivalent to 5 minus 1 divided by n, and n is the number of strips, and that will give me 16 strips, and therefore numerical integration by using the Simpson's rule is possible. Yeah, because 16 is an even number, right? So we have even number of strips. Yeah, so what exactly is Simpson's rule? Okay, let's look at the general rule of Simpson's. Yeah, so we always have the area of to be approximated by using this. Okay, it is W again. Okay, W is actually the width. W divided by 3, A0 plus 4A1 plus A2, and then again plus W over 3, A2 plus 4A3 plus A4, then plus W over 3, A4 plus 4A5 plus A6, and accordingly A0, A1, A2 and A3 are the boundaries. Okay, so when you look at it, the first boundary would appear once, and it is only normal that the last boundary would appear once or so. So what about the odd boundary? I have got 4 times. 4 times, 4 times, and 4 times. Even boundaries would appear 2 times because it is A2 plus A2 to give me 2A2, A4 plus A4 to give me 2A4, A6 plus A6 to give me 2A6 accordingly. So if that is what I observe, okay, let's look at the question that we are supposed to be attempting. It is the integration of 5 over x respect to x, taking x is from 1 to 5. I'm going to go W divided by 3, and W for this case is 1 over 4, hence 0.25. So if it is 0.25 over 3, what are the things I got to put over here? Note that when I look at 16 strips, I'm actually working with 17 boundaries. It is always like, one unit more with boundary. So if it is 17 boundaries, the first boundary would be F1. And remember, it is supposed to appear once, so F1. And the last boundary would appear once also, and it is F5. If it is first and last boundary to be deducted out of 17 boundaries, we are actually left with 15 boundaries. So if it is 15 boundaries, how many odds and how many evens? We are going to have 8 odds and 7 even, and note that they are always a term lesser or a term more. So why is it 8, 7? Why can't it be like, 9, 6, and accordingly? It is because when you talk about even and also odd term, they are always a term apart, am I correct? Let's count 1 up until 10. 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even, and accordingly, you see. So right after an odd, we are going to get an even, and right after an even, it is an odd. Hence, they are always a term less or a term more. So if it is 15 boundaries that I'm looking at, it must be 8 odd and 7 even, because odd always start first. Okay, so we're going to have 4 odds. Yeah, this would be the odd. So it is 4 summation something. Okay, so what is this something? First boundary was F1. And since width is 0.25, which is a 1 over 4, the next boundary will actually give me F1.25, isn't it? Hence, I'm going to put F1.25. And why did I add with 0.5i and not 0.25i like what we have done with midpoint rule and also trapezoidal rule is because, again, for odd to appear again, it is after an even, you see. So if it is odd even, the width between odd and an even would be 0.25. But for the next odd to appear, it is again another 0.25. Hence, width between 2 odds would be 0.5. Okay? And what about even? It is 2 summation. Okay, because right after F1.25, which is an odd boundary, I'm going to get an even boundary, which is F1.5, you see. And why did I add by a 0.5i is because it is 2wi. 2 times width of I. Why? Because for the next even to appear, it is actually 2 widths away. Okay, right? So how do I then put my I limits? Okay, it is 8 odds I'm looking at. So if I were to go with I equals to 0, it will be up until 7 because 0 to 7 will give me 8. number, and r equals to 0 up until 6 will give me 7. Plug this summation, okay, expression into your calculator and you will get the approximated area for this integral to be 8.04776. Alright, so that is about numerical integration.